So this is the 10th session on friction. In this session also I'll take up a numerical problem on kinetic friction. Okay. First I'll write down the question. Okay. The question is this. A horizontal plane with friction coefficient mu. A horizontal plane with friction coefficient mu supports two bodies. This question is of Irodove. Okay, I'm just reading the question from Irodove. I'm writing down the question. Then I'll fully solve it. Okay, fine. Two bodies. Okay, a bar and an electric motor. A bar and an electric motor with a battery on a block. A thread attached to the bar is wound on the shaft of the electric motor. The distance between the bar and the motor is equal to L. The distance between the bar and the motor is L. Okay. When the motor is switched on, the bar whose mass is twice that as that of the other body starts moving with constant acceleration W. How soon will the bodies collide? Will the bodies collide? That is the question mark. Okay. This is therefore the given question. So all the details of the question have been written down here. Fine. All right. So now what I'll do, I'll draw the diagram of the situation. I'll rub this. Okay. So first I'll draw the diagram of the situation and then I'll solve the problem. See, this is the bar. This is the side view of the situation. This is the bar. and here there is a block on which there is a battery, motor, all those things are there. Okay, here motor is there. This is the string you attach it, passes over the motor shaft, all the details are given. Here there is a motor. This is the string which is wound here. String. Initial length is L. Mass of this motor along with the battery and block, everything is M. Mass of bar is 2 times. It is specified in the question. I hope it is clear. And friction coefficient is mu here. Here also the friction coefficient is mu. Now the system is released from the motor is switched on at time 0. It begins to rotate. So bar begins to move rightward at a constant acceleration W. The question is after what time the two bodies will collide. And W is the constant acceleration of bar with respect to ground towards rightward direction. Okay. Now first one point should be noted down. See, one point should be noted down very clearly. As the shaft will rotate, this block containing the motor and the battery, everything, that will also move with some acceleration a say. It is not that only bar will move and motor will not move. No, bar will also move, and this other block containing the motor, shaft, battery, everything, that will also move. Both will move. Okay. So what we should do first, we should find the acceleration of this block containing the motor and the battery. And once we have found the acceleration, most probably it will turn out to be a constant value. Then you will use the formula ut plus half at square to get the solution. Okay. So first what I do, I draw the free body of the bar. Okay. So free body of bar is in this. This is the bar. Mass of the weight of the bar is 2 mg. N1 is the normal force on the bar due to the ground. This T is the tension in the string. String pulls bar towards right with some tension T. And here sliding friction is there. Friction is there. So friction F1 acts on this bar due to ground. Since slipping takes place, this bar accelerates towards the rightward. So with respect to ground, the bar is slipping. So ground will exert a friction F1 on the bar in leftward direction. That is simply mu times N1. N1 will just be equal to the weight of this bar, just equal to mu into 2 mg. Alright. Now what I do, I apply Newton's second law to this bar in rightward direction, in the direction of its acceleration with respect to ground. Okay. So what do I write here? T minus F1 equal to 2 mw. F1 will be mu times 2 mg. This is equal to T minus 2 mu mg is equal to 2 mw. Okay. So T is equal to 2 mw plus 2 mu mg. This first equation which we obtained now. Now what I do, I draw the free body of this motor, this other block containing motor, shaft, battery, everything. Okay. So this free body I draw it here separately. So here 8 mg acts on it. N2 is the normal force on the block due to the ground. T is the tension force on this block due to the string. Since the string has been assumed to be massless, tension at all points of string is same, T say, capital T. Now one thing, because this tension T, this block has a tendency to slip towards left. So ground will exert a friction F2 on the block towards rightward direction. Now one thing should be made very clear. One thing should be made very clear. How do we know whether this block of mass m will accelerate or not? Will it move on the ground or not? That is, will it slip on the ground surface or not? How do we know that? Now see, from this equation you can see that T is equal to 2 mw plus 2 mu mg. So T is definitely more than mu mg. You can see it. T is equal to 2 mu mg plus 2 mw. That is more than mu mg. Here what is the limiting friction here? F max. it is just mu mg, and t exceeds mu mg. So this block of mass m will also slip towards left with some acceleration a, say, with respect to ground. Is it clear? Since t exceeds to, since t is more than mu mg, t is equal to 2 mu mg plus 2 mw, meaning t is more than mu mg. So this t is more than mu mg, so this block will also slip towards left with some acceleration a with respect to ground. Okay, so what do I write here? T minus F2 is how much? F2 will be mu times N2 barabar Ma. Okay, now T is equal to 2 mw plus 2 mu mg. Substitute this T here, plus 2 mu mg minus mu. What is N2? N2 will just balance the weight of the block. N2 is just equal to mg, that is equal to Ma. Okay, so how much does A become? M is cancels out common term, 2w plus 2 mu mg minus mu mg is simply mu g. So A is acceleration of the block with respect to ground is A, which is equal to 2w plus mu g. It is towards leftward direction and it is seen to be a constant quantity. So acceleration of the block is A, that is 2w plus mu g towards left, and is constant with respect to ground. Okay. Now W is given, A also we have found out. Alright. Now I rub this one. Alright. Now see, I draw the diagram again here. This bar, this is the block. This initial distance between these two bodies is L. Bar is moving rightward at a constant acceleration W with respect to ground, and the block is moving leftward at a constant acceleration A with respect to ground. Both the bar and the block start from rest. Okay. Now, suppose they collide after time t, that time t which has been asked in the question. So, suppose they collide after time t. So, in time t, the bar will move what distance? L1, half into Wt square. Since acceleration of bar is constant W and it starts from rest, so L1 is equal to half Wt square. In the same time, the block moves a distance L2 towards left, starting from rest and moving at a constant leftward acceleration A. So that becomes 0 into t plus half At square. Here 0 I did not write, I should have written here also, but that is clear from the context as I explained it. So L2 becomes half At square, okay, and L1 becomes half Wt square. Thus L1 plus L2 will add up to L, because when they meet, then bar will move L1 distance right side, block will move L2 distance left side. So L1 plus L2 will just be equal to L from geometry. I hope it is clear. So L1 plus L2 is just equal to L. Alright. So now this I'll rub it, okay. So L1 will be equal to half Wt square, L2 will just be equal to half At square equal to L, and A is this much. So T square by 2 becomes common, W plus A barabar L. Alright, fine. Now I rub this one, okay. So now this A I substitute in this equation. L equal to T square by 2 W plus A. A is equal to 2W plus mu G. So T square becomes 2L by 3W plus mu G. So T becomes root under 2L by 3W plus mu G. This is therefore the required answer. Alright. So T becomes how much? root under 2L by 3W plus mu g. So after this much time, the two bodies will collide with each other. So this is the answer to the required question. I hope it is perfectly clear. Okay. So you go through this problem properly. If in case you have any doubt, you refer it to them in the comment box. I'll read it and clarify your doubt. Okay. So in coming videos, I'll make more and more questions. Okay. I'll make some more videos on kinetic friction. Then I'll pass over to different class of questions. Okay. So you go through them properly. If you have any doubt, you write it in the comment box. I'll explain it. Okay. So this I close it here. Fine.